Yeah, so this is Concordium Educate. Looking forward to kicking this off. I'm going to be program managing this from Encode, and Dragos from Concordium is here for today's session. If we guys could get the chat going, that'd be super great. Just drop a hey in the chats and let us know where you're joining us from. Yeah, that'd be great to get that going. So I'll do a bit of an intro about this Educate series. Who Encode are and Concordium, and how this is going to sort of play out for the rest of the team, and what you guys can expect from this program. So this is the Identity on-Chain Educate program. It's going to be a 7-week program, and I hope you guys are excited to get this all kicked off and underway today. So this is run in partnership with Concordium, and hopefully by the end you'll have a deep understanding of sort of the on-chain identity, Concordium's protocol level ID layers through to their sponsored transactions and their more advanced technical concepts. So there's going to be a series of webinars like today. They're all going to be running on Tuesdays at 4 p.m. UK time, UTC, which is 12 p.m. EDT, and lots of other different time zones out there. Just make sure you note that the time zone changes in the UK at least next Sunday. So they'll start again. If you're in the UK base, they'll be at 5 p.m. next weekend. Otherwise, same time as the rest of you guys. And these series of webinars, they're going to cover a variety of different topics, which you guys can all learn about. So we'll be covering how identity works on a public blockchain using zero knowledge proof, how protocol level tokens and why they matter for financial applications, sponsored transactions for a better UX, X402 payments for AI agents, and cryptography, and that makes this all work together. So this program is going to work in a way which you guys will get a certificate at the end of it, which you can stick on your LinkedIn profile. And this is a recognized credential for on-chain identity. Attendance is very highly sought after, and it will make a difference to your graduation prospects at the end. And so unreported absence will slightly count against your graduation eligibility. If you do know that you're going to be absent for one of these webinars, just send me an email or drop me a DM on Discord, and I'll be forgiving, hopefully, for you guys. And I hope you guys are all on the Discord. We have a Discord page. It's on the platform, the Encode Club platform, where you can find where you guys have joined all this from. And we have a Discord which should be nice and active. You can do introductions there, see who else is on this, ask any technical questions, and give me a shout if you have any questions which you might think I might be needed for. So yeah, for today, this is going to be a quick, well, I think we've got an hour or so introduction to the Concordium blockchain, covering the core concepts, design principles, and what makes the Concordium different from other public blockchains. And then at the end of this all, we'll have a bit of a Q&A session. So if you have any questions, drop them in the chat at the end, and I'm sure Dragos can answer these questions for you guys. So I'm going to hand over to him now, and yeah, I'll see you guys at the end, and I'll butt in if needed or anything like that.
Thank you for the introduction, Charles.
Pardon?
Thank you for the introduction. Yeah. Let me just share my screen now.
Wonderful. I will leave.
Okay. Can you see my screen?
Yep, we can see your screen.
Okay, so this first lesson of the Concordium Educate series will be a bit smaller than the rest. For now, we just want to go over an introduction to Concordium. So what the chain is all about, and for you to get a better understanding of the technicals and the core principles. Now, why does Concordium exist? So the problem with public blockchains today, as we see it, is most of them are built either for anonymous or pseudonymous accounts. So this introduces regulatory friction. If it's going to be fully anonymous, then it will be quite hard to have a very spread out use case. On the other hand, if it's going to be pseudonymous, people aren't going to have privacy, and all of their transactions are going to be out in the wild. This leads towards difficult enterprise adoption, lack of widespread use case adoption, and it doesn't account for compliance at an application and or a smart contract level. Now, what does the market need? So a big point is accountability whilst maintaining privacy, auditability, finality, so all transactions should be final, and then protocol level compliance. Now, what is Concordium? So Concordium is a public and permissionless blockchain platform designed for both business applications and public use. It combines privacy-preserving features with regulatory compliance, fast transaction processes, and cost-effective operations. So for the core design principles, we have privacy by default. Now you initially hear it's an identity chain, so you might think that it's not going to be fully private, but actually it is, and that's the entire point of it. There is accountability, however, only when enforced by law. So in cases where, for example, some crime happens behind the transaction, there is a way to actually find out who owns that account. But for starters, every account is private. Fast finality, so it's actually going to be just 4 seconds for every transaction. We have predictable transaction fees, so the transaction fees are all pegged to the euros. Regulatory ready infrastructure, and also we have smart contracts which are Rust based. Now, some key statistics. So for the core of the chain, we have up to 2,000 transactions per second. There's 4-second finality for each transaction. So block time on Concordium is around 2 seconds. And you just need 2 block confirmations in order for a transaction to be marked as final. And then the transaction fee for every transaction, no matter the size, is always going to be 1 cent. Now for usage, Concordium has been around for a while. So there are over 150 million transactions, more than 100,000 accounts. 11 PLT stablecoins. Now that PLT term might confuse you. We call them protocol level tokens. So it's quite a different implementation of stablecoins from what's out there in the market. And there are more than 9,000 smart contracts. So for the ecosystem, who are the key players and what are the use cases we're going towards? First of all, let's talk about merchants. So the use case for this will be accessing age-gated content without compromising privacy. As you've seen in the UK, for example, laws that have been introduced are leading towards having to check your ID. So for example, let's say you want to buy a bottle of wine. Then at the moment, you might go on some websites and they will ask for all of your ID information. You can't be 100% sure that it will be stored securely. With Concordium, we can do zero knowledge proofs on the ID, whilst the ID itself is only stored off chain, so nothing is being public. Then we have exchanges and merchants. The use case for this is having enhanced know your customer checks using know your customer as a service for onboarding. And for Web3, you can do cross-chain account verification. So it all links back to the one identity that you have. Now for the technical architecture, we have the API sitting on top. Then we have the execution layer, but interesting here, this is paired with the identity layer. For the execution layer, this accounts for transfers and all of the smart contracts, whilst the identity layer is identities and then accounts on top of that. Then we have the consensus layer with the Concordium BFT consensus protocol, which we'll discuss in the next couple of slides, the network layer, and at the end, it's all connected to the internet. Now, the execution layer. This allows users to interact with the platform through its API, so processing transactions and running smart contracts. We have a bunch of SDKs which are available for anyone to use. It uses WebAssembly as its foundation, allowing developers to write smart contracts in Rust. The identity layer, which is something quite unique, I would say, this manages user verification and privacy. So it works with external identity providers who verify users' real-world identities. This information is stored securely off-chain by identity providers, while on-chain transactions maintain user privacy. Now, a question might arise here, why not store all of this identity information on-chain? Well, if you do that, then you might get to a point where initially you say, I'm over 18. And then at some point, while you go on another website, you say your name. Then at some point, you say your location. That could lead a fraudulent attacker to actually build a profile about you. So that's why all of the identity information is stored securely off-chain. The only way for the identity to be revealed is through a regulated process involving multiple authorities that only gets started in case a law has been broken. At no point does Concordium see or hold any identity information about its users, nor does the identity providers knows which accounts are opened by which users. So the way it goes is you go to the wallet, you verify your identity, and then when you create an account, the identity provider, even though he has your identity, is not going to know that it's actually you behind that account. That can only be revealed through the process with regulated entities. Now, for the architecture, the consensus layer, this ensures that all of the nodes agree on the state of the blockchain using Concordium BFT. This is a novel proof of stake Byzantine fault tolerance consensus protocol. This protocol selects validators to create blocks based on their stake. Then it verifies these blocks and finalizes them quickly, just around 2 seconds per block. The system remains secure as long as less than 1/3 of all stake CCD is controlled by malicious actors. So as long as what would be basically 66.7% of the stake is controlled by normal users, the system will be safe. Then we have the network layer. This handles communication between nodes. It includes a peer-to-peer system for sharing messages and a catch-up mechanism that helps nodes stay synchronized within the network. Even after being offline, Concordium currently has two types, Concordium currently has two types of nodes. So we have the Concordium node and the validator node. The validators are the nodes that actually stake Concordium as well, and they can validate by being a part of the chain. There's also the option of being a delegator. So that would be where a validator opens up a pool and you just want to do staking. So you don't even need to run your own node, and then you can delegate your CCDs to a validator and get rewards based off of that. Now for the tooling landscape, we have the dApps first of all. So here for tools, we have quite a wide variety of SDKs. So we have TypeScript, Rust. This would be the two flagship SDKs. Then we also have Kotlin and Swift, Java, .NET, Go, and the Rosetta API standard. For infrastructure, for dApps, we have the Concordium node. This will be the main bit that communicates with the blockchain, of course. Then we have the verifier service. This is a service that we provide that anyone can host. And then basically, when you get a zero knowledge proof, you can send it from your dApp to the verifier service, and you will just get a yes or no answer back. And last but not least, we have the sponsor service. This has been introduced along with Protocol 10. So what this means is that you can send a transaction whilst a sponsor will cover the fee. So in this case, for example, if you're a merchant, let's say, or if you're building a dApp where a user just wants to pay, he just wants to hold stable coins, so PLTs, then you could run a sponsor service and the user would just need to get PLTs, and then the transaction fees in CCDs will be handled by the sponsor. Now for the merchant, we have an additional tool called the Concordium Verification Web UI. Now this allows a merchant to quickly integrate with Concordium with all of the other SDKs. So a merchant would just need to connect to this one and the identity verification and everything in order for a user to just access a website and then to have a verifiable proof at the end that the user was actually 18 can be done just through this one TypeScript SDK. For the infrastructure here, we still have the Concordium node, the verifier service, and the sponsor. So nothing changes there. For exchanges, we have the same SDKs, but here an exchange would only need a node. And then for wallets, we have a different set of SDKs. So since we're talking mobile development, we have Kotlin and Swift for Android and iOS. Then we also have a TypeScript SDK. For the infrastructure, we also have one extra bit called the wallet proxy. This is, again, open source as all of our other services. And what this allows you to do is if you want to run a wallet and integrate Concordium into it, it's a very useful way. It provides an API in which you can get, for example, all of the transactions for an account instantly, and you can get a lot more complicated than that. Now, getting started with Concordium. So something that I would recommend if you want to start development, especially before all of the next courses, just to get a feel of how the SDKs feels, how the infrastructure is feeling, you can set up a local chain. So in order to help developers get started as quickly as possible building on Concordium, we have created a Docker Compose package to spin up a local Concordium blockchain network. Now, this package will include the latest protocol node with gRPC, a test identity provider, so you don't have to do any configuration yourself, a running wallet proxy, CCD scan, which is the official blockchain explorer for Concordium, and the PostgreSQL database for wallet proxy and CCD scan, so that stores all of the transactions, a Postgres admin for database management, and at the end, a web server for PLT token metadata. So what that allows you to do is to actually have an entire chain running locally. At the end, you'll even be able to create your own PLTs, and you can do development without having the hassle of going on testnet or mainnet, and you don't have to spend anything. You can just use it directly. Now, for a quick demo, we're going to be going through the local chain. I'm seeing a message from the chat. This is where you can find the Docker Compose. So this is public. I will have some QR codes in the next slides as well. This is the local stack. The important bit of this will be actually the Docker Compose itself. This is quite complex, but I urge you to go and have a read through it. But running it is actually very easy. So I will go through the steps and then I will show you one that's actually running already. So for the prerequisite, you're just going to need Docker, JQ, then you will need a Concordium client. Now, I haven't mentioned this before. The Concordium client tool is a CLI that we offer. You can do anything that you can do it with the SDKs directly through the CLI if you don't want to use any of the SDKs. Then you need to download the Genesis Creator tool. You can find both of these in our developer documentation. This is a bit from upgrading for Protocol 9, but if you're running it for the first time, you're not going to need this. And now for the infrastructure. So you just need to clone the repository. After you've installed all of the prerequisites, you can initialize the Genesis block. We have a script already. You just need to run that, and that's it. And then you can start up the local net. Then you can verify all of the services are running. All of the containers should show status up. So as an example, here we have an actually running local net. So I ran the initialize script. I decided to do this before, as it would take a bit more to actually run the Docker Compose and to pull off all of the images. I verified all of the versions, then I started it. You can see that all of the services are started and healthy. Then you can do Docker Compose PS quickly, just to check on the status. Then, this is quite cool, I would say, we have a script which allows you to create your own protocol level token. So after you've went into the wallet and created that account, you will be coming back here. I will show you the wallet afterwards. And here you can choose a token identifier and create your own protocol level token. At the end, you will send the address for the governance account. And then what this will do is it will actually spin up a Concordium client, which will send the transaction to your local running node, and you will have a new stablecoin created. All right. And now let's see how this actually looks inside the wallet. So here we have the Concordium browser wallet. You can get this from our documentation, and I will also share a couple of QRs in the next couple of slides. Now, one thing to mention here, when you do this, you need to configure the custom network before setting up your seed phrase. So for the ones that are already using the Concordium web wallet, you can get another version of the extension and start fresh, basically. And all that you will do is you will go to Concordium custom. You can fill in all of this information. Everything is running on localhost, as you can see. And then you can request an identity and create an account. So here, I've already created 2 accounts. We can do a quick transfer between them right now, for example. So let's send 1,000 CCDs. Right, so this was already finalized, and you have this working again fully locally, so no testnet, no mainnet. It's quite easy to set up. As you can see, the amounts have changed. And just to check the custom networks, so you go on the network tab, you look at custom, and you will see this green lock here. This is basically all connected to localhost. Oh, thank you for posting the link in the chat. Yes, that's exactly the link for the local stack. As you can also see here, we have a protocol. Yes, this is a sandbox environment, Nash. We have a protocol level token, called it PLT test, and we can even create another one. So let's copy this address. We can now go into VS Code, and we can run the script directly from here. So let's call it test token 2. We can have a descriptive name. So this will be a token in a sandbox. Longer description here. So everything as it would be on mainnet or testnet. Number of decimal places, let's go for 2. Initial supply, we can do 100. Now for the governance account, I copied the address before, so now I'm just pasting it. And you can verify everything at the end. And now we're gonna continue. This is actually sending a real transaction to your local stack. And now if you give it a couple of seconds, you can see that it was actually done instantly. We have test token 2 in here, and it's gonna be 100. Great. So for anyone who wants to start developing, my suggestion would be to have a look at the local chain, and then you can also go through the rest of the GitHub. So actually, yeah, you will get the PDF of this PowerPoint at the end. If we go on the Concordium GitHub, you will see some interesting repos here. So if you like smart contracts and you like Rust, you can have a look in here. There are a bunch of these are the libraries. Then we have a lot of examples of already implemented smart contracts. And then we have Concordium dApp examples. So here we have a lot of dApps which already use Concordium. In order to set them up, you can just create an env file, and instead of connecting to the testnet node or to a mainnet node, you will connect to your local host. And at the same time, we actually have a running CCD scan here. So as you can see, this is going on localhost, and this is already running with everything on the local chain. All right. Now we will go for the Q&A after the QR codes. Since I've noticed that some people already asked in the messages, we have some QR codes over here. So I will give you 10-20 seconds for each if you want to scan them. This one leads to all of our SDKs in the developer documentation. Sorry. Now here we have the rest of the SDKs along with the verification web UI. Again, you will get this presentation afterwards. Also, everything on here can also be found on the official technical documentation. So that's docs.concordium.com. For the infrastructure, you have the node, the wallet proxy. You can have a look at how the actual node is implemented. That's all open source again. So I see a question in the chat. What was the governance token? So it wasn't the governance token. It was the governance account. So when you create a protocol level token, At first, you specify an account, which will be the governance account of that token. So that will initially hold all of the tokens. And then we also have a few interesting features, which will be discussed in the webinar about protocol level tokens, but you can also have a look in the documentation directly. So for example, tokens can have a deny list. If a deny list feature is active, that means that the governance account will be able to add any accounts to the deny list, and you won't be able to send or receive from that account. Now, thank you for the presentation. Thank you for attending the presentation. This has been quite short, but it's because it's the initial lesson and we don't want to go in depth, as we'll have all of the next six sessions for that. And we can now start the Q&A if there are any questions. Can wait for a couple of minutes. So I saw a few questions under messages, but there's also a Q&A tab. So what's the difference? There's a question in the chat. What's the difference between an identity chain and other types of chains? What we're doing novel with an identity chain is that in order to have an account, you first need to verify your ID. So in this scenario, let me actually show you in the wallet. We can go here under identities. This is running on the local stack, so it's just a John Doe identity. But in order to first create an account, you will need to go in here in the wallet. And then you will create an identity. You can use this one. As you can see, this is just for testing. Obviously, when you do it on mainnet, it will be a more a process that is a bit more complicated, but quite fast to do as well. Can click on submit, and as you can see here, we're only now creating an account. So we're creating an account from an identity. That would be the meaning of an identity chain. So that's how it differs from any other blockchain where it's just an account on the chain. Just a second. All right. I see a few other questions. So how is this blockchain different from EVM or non-EVM blockchain? So this is a layer one. It's not an EVM blockchain, as Ethereum is a layer one. This is also layer one, but this has smart contracts in Rust. And we would say that a big advantage is the identity layer itself. So this actually allows accountability for anyone on the chain whilst still maintaining privacy. So as long as you just do normal transactions, it will be fully private. But if a bad actor wants to do transactions, then there will actually be a way to find out who is behind that account. Okay. Let me have a look at other questions. What components have been started? Which ones are mandatory? So we can go a bit back in the local chain. Everything in here was started. I would suggest to just use everything at first, because the Docker Compose file allows you to just do one command and then you'll have everything. If you really wanted to just spin it up quick, then the only one which would be mandatory would be the running Concordium node, but then you wouldn't be able to actually have a full chain. So for that, you would need the test identity provider, which we provide in the Docker Compose file. And that's why my suggestion would be to run all of these. And there's another question. Can you tell me the purpose of that sandbox? So the purpose of the sandbox would be, let's say you're a developer, right? You want to see how you have a dApp already maybe, and you want to see how easy it is to integrate it with Concordium. You could go on testnet usually, but then on testnet, for example, you won't have a stable coin. In order to create a stable coin, you will need to contact us, and then you can do that. But you can have this sandbox running locally, and it's literally the entire Concordium chain. So this would allow you to just do a Docker command. You would have the chain running locally, and then you can do development and you can try anything. You can try to break it. You can try doing anything. For the system requirements, I don't know them off the top of my head, but you can have a look at on docs.concordium.com on the run a node section. There you will see the system requirements for a node. But since you're just doing this locally, it's not going to be that big. So I would say that any modern PC could handle it quite easily. Let me see if I can see. Now there's a question. When the law requires, how do they interfere or get info on chain if it's private? This will be discussed in the next webinar. So there's quite a complex process, but just to give you an overall understanding, we have three big regulators, which would be, first of all, the local authority, then you would have the identity provider, and then the Concordium chain itself. So in order for somebody to actually see your identity, the local authority would have to actually raise a case, and then that would go to the identity providers, and all three of them would have to decide. So that's just an overall explication, but this will be explained in the next webinar in detail. Let me see if there are any other questions.
Okay, is that? I think that might be all the questions up. If you guys have any more questions,
yeah,
feel free to drop in the chat. Can you guys see me? I don't think you can.
Yeah, we can see you.
Anyway, thank you so much for that, Dragos. Very good insight into Concordium and sort of the background to it all. Yeah, same again next week, another webinar, same time. I think this time it's with Dragos and Daniel. Next week is going to be a deep dive into identity on Concordium's on-chain, exploring how identity works and how privacy is preserved, and the role of zero knowledge proofs in this scenario as well. So come back for that, guys, next week, same time, 4 p.m. UK time. And yeah, look forward to seeing you guys then. And as always, stay active in the Discord, ask questions if you have any, and drop me a DM if you have any specific questions that I can help with.
Thank you everyone for attending, and see you in the next lessons.
Thanks, guys. Bye.